Good morning, everyone. I am Miss Precious Dabandan, and I will be teaching grade 9 mathematics. So today, I will be teaching you about illustrating angles of elevation and angles of depression. At the end of this video, the students will be able to first illustrate angles of elevation and angle of depression. Second, distinguish angle of elevation and angle of depression. Third, we're going to solve problems involving angles of elevation and depression. And lastly, appreciate the importance of angles of elevation and angles of depression in real-life situations. I know you're all excited. But before that, let us have a quick review about our past lesson in trigonometric ratios. So this activity is entitled Light It Up. In this activity, based on the given figure, you are going to match each trigonometric functions with indicated angles, the column A, to the correct ratio in column B. So each correct answer will light our light bulb. Okay. So first is tangent A. Remember, when we discussed last meeting, we have the SOHCAHTOA. So tangent A is TOA. So opposite over adjacent. Our reference angle here is A. So A as the opposite side of small a. So small a over the adjacent, which is small b or side b. So the answer is very good. We have A over B. Next, number 2, cosine A. Correct. We have B over C. Sine P. Sine P has the ratio of P over Q. Cotangent P. We have R over P. Very good. And second P, Q over R. So now you recall the 6 trigonometric ratios. Now let's proceed to our next activity. Before we start our lesson, you're going to listen to this scenario. So I went to an IMAX theater to see a movie, Avengers Endgame. I really enjoyed the movie, but afterward, my neck was killing me. That got me thinking why. I was sitting on the front row of the theater, which is roughly 15 feet away from the screen. The bottom of the screen is 26 feet up the screen. Now, why do you think my neck is hurting after the movie? So, at the end of the lesson, you will going to figure out why my neck is hurting after I watch the movie. To start with, let us define some related terms. First is horizontal line of sight. It is a straight horizontal line that comes from the eye of the observer. So in other sources, it is also known as horizontal reference line, or some of them it is called eye level, or some books it is called simply horizontal. So if we are going to show or draw the horizontal line of sight, so suppose we have this observer. So from her eye, we are going to draw a straight horizontal line. So that is our horizontal line of sight. So this is the origin of the angles of elevation and angles of depression depending on our next term. Next, we have line of sight. It is a straight line drawn from the eye of the observer to the point or object being viewed. So again, suppose this is our observer, we're going to draw an horizontal line of sight. Okay? And for example, she see an object. For example, a bird. So if she looks at it, to the bird, it will also produce another line. And that's what we call line of sight. Okay. Another example, if she saw below, okay, she saw a dog, it will also produce another line, which is line of sight. So depending on an object or point the observer viewed. Okay, it's either above the horizontal line or it's either below horizontal line. Now let us formally define what is angle of elevation. So it is an acute angle theta, an acute angle formed between the horizontal line of sight and line of sight above the horizontal. So suppose again this is our observer. We're going to draw an horizontal line of sight, which is represented by this red line, and an object. Okay, if she looks up to the bird, it will also produce a line, which is line of sight. And then from line of sight, it will also produce an angle, which is angle of elevation. Okay, so from the horizontal line of sight, you look up, it will form an angle of elevation. An example of this is when you look at the ceiling, then you saw a lizard. It is an example of elevation. Another example is when at night, when you see a moon. That is the angle, that is an example of angle of elevation. Now let's proceed. Angle of depression. So it is an acute angle theta, again an acute angle, formed between the horizontal line of sight and line of sight below the horizontal. So if the angle of elevation is upward from the horizontal line of sight, in the depression, we will be considering the angle below the horizontal line. So let us illustrate. Suppose this is again our observer and then a dog. Let us draw an horizontal line of sight, which is represented by this red arrow. If she looks at the dog, this is our line of sight. The angle formed here going down is what we call the angle of depression. Okay, so the moment you look down, or if the line of sight is below, that's form an angle of depression. An example of this is when you saw an ant below the ground or on the ground. So it forms an angle of depression. So the moment you look down, that produces an angle of depression. Now let us illustrate. So how are we going to illustrate angle of elevation made by a boy flying his kite? So first, let us illustrate the object involved. So in this example, we have the boy and a kite. Okay, we will start our horizontal line of sight in the eye of the observer, which is the boy. After that, the line of sight would be to the kite. And this angle now is the angle of elevation, since our angle is formed above the horizontal line of sight. Number 2. So illustrate the angle of depression made by a boy on the top of a cliff to its camping site. So first, let us illustrate the object. So we have here the boy, which is in the top of a cliff, and then a camping site. Its camping site. So in order for us to draw an horizontal line of sight, we will first start at the eye of the observer, which is the boy. Yan. And the line of sight from a boy to its camping site. And as you can see, the angle between the horizontal line of sight and line of sight will will be the angle of depression because the line of sight is in downward direction. So therefore, this acute angle represents the angle of depression. Let us show the relationship of the angle of elevation and angle of depression in one illustration. Is it possible? Yes. Okay, so suppose we have a girl and a bird. Okay, so from the perspective of the girl, let us draw an horizontal line of sight. And if she looks up to the bird, it will produce a line of sight and it can make an angle of elevation. Now, from the perspective of the bird, okay, again, let us draw an horizontal line of sight. So, if the bird looks down to the girl, it will produce an angle of depression. So, how are we going to relate the angle of elevation and angle of depression at this instance? So, take note that the horizontal line of sight are made by the girl and from the perspective of the bird are parallel. So therefore, we can say that the angle of depression represented by the green angle and angle of elevation represented by the yellow angle are congruent. Okay? Because the line of sight serves as a transversal. Remember that the angles have the alternate interior angle theorem. Okay? So, the two parallel lines, which is the two horizontal lines, are parallel. They are cut by a transversal, which is the line of sight. So, therefore, we can say that their measures are equal. So, why do we need to know the relationship of angle of elevation and angle of depression shown in one illustration? Because it is necessary when we are solving problems dealing with angles of elevation and angles of depression. Now, in our objective, we already accomplished first, illustrating angles of elevation and angles of depression, and distinguish between angles of elevation and angles of depression. So, reminder, when we are solving, we need to use a scientific calculator because we cannot get the measure or values of the other angles since we can only compute for special angles such as 30 degrees, 45 degrees, and 60 degrees. So how about the other angles that are not special? So that's why we need a scientific calculator. Okay, so in solving, make sure that your scientific calculator is always in degree mode or deg mode. So if not, press mode, then choose deg. Okay, so let's try. So try getting the value of sine 45. And we all know that sine 45 is square root of 2 over 2. So if you get the same value of 0.70167 and so on, then you are ready to solve angles of elevation and angles of depression. Okay, let's have this example number 1. So point A on the ground is 10 meters away from the base of the building. So we have the point A and the building. It is 10 meters away. So 10 meters would be our horizontal line of sight. So the line of sight would be from the point A to the top of the building. Okay, after that, we will produce an angle of elevation that measures 38 degrees. Okay, so how are we going to solve for the height of the building? Is it possible to compute for the height of the building? Yes, it is possible by the use of trigonometric ratios. Remember that the three basic trigonometric ratios, which are sine, cosine, and tangent, right? If you can see, we can form a right triangle here. So we have an acute angle and the sides of a right triangle. So if we relate the unknown side, which is h, and the given side, which is 10 meters, with respect to the given acute angle, which is 38, okay, 38 degrees. So we should remember that our reference angle here is 38 degrees. And like what we do in 6 trigonometric ratio, okay, so the opposite side of this reference angle is h. How about 10 meters? If we relate 10 meters to the reference angle, that would be the adjacent side. So in the given illustration, the given side is given, the opposite side is given, and the adjacent side is also given. So what trigonometric ratio does an opposite and adjacent side have? So very good, that is tangent. So TOA, right? Tangent theta is equal to opposite side over adjacent side. So now let's solve. So first, we're gonna substitute the given. So tangent 38 degrees is equal to the opposite side, which is h, and the adjacent side, which is 10 meters. Now let's multiply both sides by 10 meters using multiplication property of equality to cancel out 10 meters or to remove 10 meters in the denominator. Okay, so 10 meters divided by 10 meters, that would be 1. So we can cancel out this. And then we have 10 meters times tangent 38 degrees is equal to h. Now 10 meters times 0.7813. This one is from tangent 38, right? When we solve using scientific calculator, we have the result of 0.7813. Then let's multiply 10 times 0.7813. Then the result is 7.813 meters. Okay, so the height of the building is 7.813 meters. Example number 2. A ladder leans against the 6-meter high wall and reaches the top. If a ladder is inclined with the ground at the angle of 60 degrees, how far is the foot from the wall? Okay, so let's solve this. Again, our given here is 6 meters as the height of the wall and 60 degrees for angle of elevation. And we let B for the distance from the foot of the ladder up to the wall. Okay, so our reference angle here is 60 degrees. So if this is our reference angle, the opposite of that, okay, the opposite of 60 degrees, or our reference angle, is this one, this side, 6 meters. So 6 meters would be our opposite side. Okay, and how about D, this side. So, with respect to our reference angle, D here is our, very good, our adjacent side. So, now we know our opposite side and adjacent side. So, again, in the previous example, we use tangent, right? TOA. So, tangent theta is equal to opposite side over adjacent side. So, tangent 60 degrees, our reference angle, is equal to 6 meters as our opposite over adjacent. Then, using multiplication property of equality, we're going to multiply both sides by d to remove our denominator d, right? Since d divided by d becomes 1, we can cancel this out. Okay, so that would become d times tangent 60 degrees is equal to 6 meters. And then, we're going to divide both sides by tangent 60 degrees. So, d is equal to 6 meters over tangent 60 degrees. Now, this 60 degrees, tangent 60 degrees, we can solve this through the use of scientific calculator, right? So, you're going to type on your scientific calculator, tangent 60 degrees would become 1.7320 or 1 and 7,320 10,000ths. Okay, so our answer would become D is equal to 3.4641 meters. So the distance from the foot of the ladder up to the wall is 3.4641 meters. Example number 3. From the top of a fire tower, a forest ranger sees his partner on the ground at the angle of depression of 40 degrees. Okay. If the tower is 45 feet in height, how far is the partner from the base of the tower? Okay, let's solve this. So again, our reference angle is 40 degrees. So with respect with 40 degrees, x would be our x would become our opposite side. Okay? And if x is our opposite side, then 45 feet with respect to 40 degrees, our reference angle, that would become our adjacent side. So if we have the opposite side and adjacent side, again, we're going to use a trigonometric ratio of TOA or tangent theta, right? So tangent theta is equal to opposite over adjacent. Now let's substitute the given. We have tangent 40 degrees is equal to x over 45 feet. Then let's multiply both sides by 45 feet. Again, using multiplication property of equality. Okay, since 45 feet divided by 45 feet would be 1, so let's cancel this out. Okay, 45 feet times tangent 40 degrees is equal to x. Now, this tangent 40 degrees, we can solve this using scientific calculator. So, that would become 0.839. So, 45 feet times 0.839 would become 37.7535. Example number 4. So, a passenger on a ship observes a 1,800 meter high lighthouse. So, that stands on a hill, which is 3,700 meters away from the ship. Find the angle of elevation on the top of the lighthouse from the ship. So first, let us illustrate the given problem. So we have the lighthouse and the ship. So it says here it has a 1,800 meters high lighthouse, and the distance from the lighthouse up to the observer, which is the passenger on a ship, is 3,700 meters. Now we're going to find the angle of elevations. So the given values are 1,800 meters and 3,700 meters. So we're gonna find the angle of elevation of the top of the lighthouse from the ship. Okay, so our reference angle is this, the theta. Since this is our reference angle, the opposite side of that is 1,800 meters. If this is our opposite side, the 3,700 meters would be our, very good, our adjacent side. So now we know our adjacent and opposite side. We're gonna use the trigonometric ratio of tangent or TOA. So tangent theta is equal to opposite side over adjacent side. So let's substitute. Tangent theta is equal to 1,800 meters as our opposite over 3,700. Now, using a calculator, let's divide 1,800 divided by 3,700. So that is equal to 0.4865. Now, to get the value of the theta, we're going to multiply both sides by inverse of a tangent, or we read this as arctan. Okay? Since tangent, inverse of a tangent times tangent would be 1, so theta na lang. So tangent or arctan times 0.4865. So using your calculator, you're gonna press shift, or some calculator has a second. So press shift, then tan to get the inverse of a tangent. Okay. So the result is approximately 25.9429. Okay. Or simply 26 degrees. So this 26 degrees is our angle of elevation of that from the ship to the top of the lighthouse. For your activity, you're going to illustrate and solve for the following problems. So number 1, a tower is 15.24 meter high. At a certain distance away from the tower, the observer determines the angle of elevation, which is 41 degrees. So how far is the observer from the base of the tower? And the second question is, an airplane is flying at a height of 4 kilometers above the ground. The distance along from the ground from the airplane to the airport is 6 kilometers. What is the angle of depression from the airplane to the airport? So you can pause this video to answer this problem. Are you done? So let's answer this question number 1. So a tower is 15.24 meters high. At a certain distance away from the tower, the observer determines the angle of elevation, which is 41 degrees. How far is the observer from the base of the tower? So first, let us illustrate. So we have the tower and then the observer's eye. And the tower is 15.24 meters. So from the observer's eye up to the top of the tower, it has a 41 degrees of angle of elevation. So our reference angle is 41 degrees. And then we're going to use again the trigonometric ratio, which is tangent or TOA, since our target is to get the distance from the observer's eye up to the tower. Okay, so now let's substitute the given values. So for tangent 41 degrees is equal to 15.24 meters divided by d, which is the distance. Then let's multiply both sides by d. Since d divided by d is 1, we can cancel this out. Next, we have d times 41 degrees is equal to 15.24. Since our target here is the value of d, we're going to divide both sides by tangent 41 degrees. So we're going to cancel. So that is 15.24 over 41 degrees. And 41 degrees, tangent 41 degrees is 0.8693 degrees. So again, using calculator, we're going to get the distance of 17.53 meters. So that is the distance from the observer's eye up to the base of the tower. So let's answer question number 2. So an airplane is flying at the height of 4 kilometers above the ground. The distance along the ground from the airplane to the airport is 6 kilometers. What is the angle of depression from the airplane to the airport? So first, let us illustrate the given problem. So we have the airplane and the airport. Okay. So the airplane is flying at the height of 4 kilometers above the ground. Okay. The distance along the ground from the airplane is 6 kilometers. Now, we're gonna find the angle of depression. So first, from our reference angle, which is theta, 6 kilometers would be our opposite side. And with respect to our reference angle, 4 kilometers would be our adjacent side. Since we already know our opposite side and adjacent side, let's use our trigonometric ratio tangent or TOA. And then let's substitute. So 6 for the opposite side and 4 kilometers for the adjacent side. Now using calculator, 6 divided by 4 is 1.5. So tangent theta is equal to 1.5. Now to get our theta, let's multiply both sides by the arctan or the inverse of a tangent. So theta is equal to arctan times 15, 1.5. Okay, and using a scientific calculator, you're going to input shift and then tan to get the inverse of a tangent, and then 1.5. So it is approximately 56.3099 degrees, or simply it is 56 degrees. So the angle of depression from the airplane to the airport is 56 degrees. Now you're done with your activity, let's go back to our previous scenario. So you're gonna figure out why is my neck hurting after I watch the movie. Let us recall. I was sitting in the front row seat of the theater, which is roughly 15 feet away from the screen. So from the bottom of the screen up to the screen is 26 feet. So why do you think my neck is hurting after I watch the movie? So given these sides, we can have now a right triangle. So using this given, we can now solve for the angle of elevation. Since from this theta, the opposite side of it is 26 feet. If this is our opposite side, so 15 feet will be our adjacent side. So for our solution, so we're going to use tangent theta. So TOA, tangent theta is equal to opposite side over adjacent side. Now let's substitute the given values. So tangent theta is equal to 26 feet divided by 15 feet. So using a scientific calculator, we can have tangent theta is equal to 1.7333 and so on. So next step is we're gonna multiply both sides by arctangent. So arctan or inverse of the tangent. So theta is equal to arctan times 1.333. So using your scientific calculator, again, we can have 60.0179 degrees or approximately 60 degrees. So that's why my neck is hurting because I was too close to the screen. So I have an angle of elevation of 60 degrees. So now we're done. We are done in solving problems involving angles of elevation and depression, and also appreciate the importance of angles of elevation and angles of depression in real-life situations. So now let us recall. So angle of elevation is formed by the eye level or horizontal line and the line of sight of the observer when he looks at an object that is located higher than him. And for angle of depression is formed by the eye level or horizontal line and the line of sight of the observer when he looks at an object that is located lower than the observer. So for your evaluation, answer this on a sheet of paper. And for your assignment, you're gonna answer this. Guess the words from Module 5, page 12. Okay. Thank you, and that's all for today. See you next video lesson.